Welcome everyone to part 2 of our 2020 Google Summer of Code final showcases. This is the second of our 4 showcases to allow our 2020 class of interns to demonstrate the great work they completed across their projects throughout this past summer. So these were the projects that we had presented on our first showcase this past Tuesday. We had both Karan and Muskan demonstrate the work that they'd done on the web app. Abhijit demonstrated the work he had completed on the digital bank UI on top of Fineract CN. And then Chinmay showcased the work on our Android SDK, and Devansh the latest progress on the mobile wallet 5.0. And today we're going to have Yash, who's going to be sharing the efforts he led on our computer vision PPI. Garvit, who's going to showcase the latest progress on our mobile banking app on top of Fineract CN. And likewise, Shivangi is going to showcase her efforts on top of the mobile banking app on Fineract 1.x. And then Mantan is going to walk us through the extensive refactoring as well as the Swagger API documentation that he's completed. And then returning back to some of our mobile development, Ankur is going to demonstrate the progress he made in building out a reference open banking fintech app. And then our final showcase today will be Nasir demonstrating his efforts in the progress made on migrating the ORM to Eclipse Link from OpenJPA. And then to give you a glimpse of the showcases we'll be having this upcoming week, next Tuesday, we'll have the progress demonstrated from our online banking app. And then Shashank is going to walk through all of the enhancements he's made to the latest version of our Android field operations app. And then Ashwin will showcase the changes made in converting all of our customer-facing apps to Kotlin to leverage the multi-platform capabilities that are now available on that framework. And then Subham is going to walk us through the GSMA mobile money API connector he built on top of Payment Hub EE. And then we're going to have Mehul showcase the credit scorecards built on machine learning that he's worked on. And then our final showcase for this year will be next Thursday. And we're going to start off with one of our web projects, which is the configuration wizard, which has been built by Ashutosh on top of the new web app UI. And then we're going to have also the screens that he built for the operations UI for Payment Hub demonstrated. Ahmad is going to go through the many extensive enhancements he built onto the Android field operations app for Fineract CN. And then on the Fineract side, Percy is going to take us through the improvements he made on both code quality and extending more testing coverage. And then last but not least, Rahul is going to go through the efforts that he led around the integration with credit bureaus, centering around the Myanmar credit information exchange. So I just want to once again thank all of our interns from both the MIFOS initiative as well as Apache Fineract for all of their accomplishments this summer. And we're looking forward to engaging with you and onboarding you as long-term contributors and maintainers and leaders in our open source communities for many years to come. So with those brief introductions, I will pass it over to our first presenter of the day, which will be Yash. So Yash, if you want to begin sharing your screen, I think you should already be a panelist and should be able to showcase your efforts right now.
Yeah, hello, am I audible?
Yeah, we can hear you, Yash. And then
so
while Yash is getting his screen shared, his project this year was a continuation of a project we started last.
Is my screen visible now?
Vision PPI. Yes, it's visible, Yash. So looking forward to the demo.
Yeah, so I'm Yash. I was working on the computer vision based PPI tool, which is basically a tool which will help officer to automatically fill the PPI surveys, the poverty probability index surveys. So first of all, the project was divided into two parts: the data collection part to train the model, and then the Android app. So the Android app is the end product. So I'll start with the Android app itself. So the first thing I did was to revamp the entire login part of the app, because the way it was working last year, the login was just limited to just the main API. Like you cannot change the base URL in case the API goes down or anything. So I factored it using RX Java and retrofit, so it's more robust now. And next, as you can see, like the UI has been completely revamped. Like earlier we had a navigation bar, now we just have a bottom navigation bar layout. So yeah, and other changes have also been made to make the screen look better. So we continue, and here you can just go view your own profile, and then you can search and see the about screen for the app. Next thing, you can start searching for a client via their username or their account number. So you can just open any profile and see their details, and then start taking a new survey. So this is the main PPI survey form. Each PPI survey has 10 questions which field officer will have to fill. So sometimes an officer might miss certain questions which are related to objects present in a owner's house. So those questions can be automatically filled by taking some photos. The phone can automatically detect what objects are present. So that process has been automated now, as you will be seeing shortly. So these questions have to be filled manually, but questions like this question: what type of construction materials are outer walls made of? Like a user can just take the photo of the outer walls of the house and show and analyze it, and you can see what material it will be made up of. And then this question can also be detected the same way, and so on. So next we'll have a look at the image analysis part, in which you can upload the images and see how it works. So you can either click an image directly using your camera. So just click an image, use your camera and analyze it. So analyze it, and you can see the detector detects that it's a monitor, and it will accurately tell you what it is. And next part is like, generally you will not an officer will not be doing this. The officer will probably click a group of photos and then analyze them after selecting the images from the gallery. So upload from gallery, select an image of a television, a phone, a television set again, and a washing machine, refrigerator, salad set, and this place we have selected a raw house, a kacha house. So, and now I'll analyze the images. So as you can see, it will tell you what it is pretty accurately and detect what the thing is. The cellular phone is detected with 78% accuracy, and so on. All objects will be detected pretty much accurately. And all of this is happening on device itself. Nothing is being uploaded anywhere. All the data will be analyzed on the user's device itself in real time. So once this detection has been performed, you can just like now we'll see how the questions will be answered automatically. Here, it was a kacha house, so the outer walls are made up of predominantly light materials, which is the first option. So the user can just see what the computer said and mark that option here. The next, there was one Sala set present, which is less showed in the analysis part, so just select yes. The next part is a refrigerator and freezer, so both were present, of course. So it shows both are present. If only one thing is present, it will show that either refrigerator or washing machine is present. We'll see that example too later on. Then how many telephones were there in the family? I uploaded images of 2, so that's what it showed. Up next, we'll take another example. We'll upload from gallery a washing machine, a telephone, and this time we'll select a normal house. So washing machine is detected with almost 100% accuracy. I have displayed the top 10 results here just for the sake of convenience. Actually, we just needed top 2 or 3 results at max for the program to run, but I displayed top 10 for convenience. Then the cellular telephone has been detected with the 71% accuracy. And here you can see detected this house properly. And like the model is trained so that it will detect, it won't say it's a house or something. It will say it's a palace or a patio or a hut or something. So I like made the app make like recognize a collection of such words, like it's a palace or a patio or a hut or something. It will automatically detect, say that it is a pakka house. So we'll see how this looks in the questions now. So here, it was a pakka house. So the outer walls are made up of predominantly strong materials. You can select either of the two options depending on the user's discretion. Then I didn't select a salsa set. So this time there is no salsa set. Then this time I selected only a washing machine and not a refrigerator. So only a washing machine is present. And then I didn't select anything related to a TV or a VTR, VHS or DVD set, so neither is present. And finally, I just selected one image of a telephone, so it detected a single image. So the rest are a few miscellaneous other features of so like, yeah, basically this is what the application does. You can just automatically upload images and see everything. You can also see the profiles of any of these people and like see the details. And yeah, you can also share the application using whatever social media apps or sharing options you have in your phone. And the last thing is the logout. So you can log out. So earlier there was no, the credentials were not saved, so I also have saved the credentials, so users does not need to log into the app every time they wish to use it. So this was the mainly the part of how the Android part works. Now I will go into the data collection part. So the next part was to collect data. So earlier what was being done, there was a Jupyter notebook, but the notebook was like, you had to, there was different cells, different techniques in each and every cell. So if you have a data set of say 1,000 images, you'll have to press the each of the cell 1,000 times for each of the images, which is not a very practical approach. So what I did, I made a data collection. I converted image just so that you can see what each operation will do. So the first is like, if we take an input point, it should look like this, then it will perform these all operations. And yeah, this is just a display of how it will work. The actual script that does this is a Python script, which I'll just execute and show you. So this is my home directory. Here the input, this is the input image. I've just taken one image for showing purposes. So here we go. I'll just show the script also. This is the script, the generate images.py, which will actually prepare a data, which will take in as many images are present in the input directory and store them in the output directory. So I'll just run the script and show you how that works. So I'll run this. The input is here and the output is the output directory. It can be anything the user wants. So it's, as you can see, it's pretty fast to do everything in real time itself. So here we go. So as you can see, the input image has been like augmented a lot of times. It has different effects. It has been made inverted. It has, the contrast has been changed. The brightness has been changed. It has been cropped, random zooming and stuff has been done. So basically this increases our data set. So the image labeling model is basically a convolutional neural network which will recognize patterns. So in the image, so this will train the network to accurately detect each and every pattern present. So yeah, as you can see, one image gives us 36 outputs. So this will give, even if we have a limited data set, it will give us a whole variety of output images which we can use to train our network further. So yeah, this is the main part, the image augmentation, and then the Android app. Then I trained a pre-trained TF-like network called MobileNet on my data set. So I performed transfer learning for that, and as you can see, the results are pretty accurate. It almost gives, generally it will give you very accurate results. And so the last part of my work was documenting the project. There was hardly any documentation present. So yeah, I made the README. I like guided showed the entire dev how to set up the project, and also provided a few resources on how I went about building the project, so other contributors can see what they can do to get started with the project. And then I made the project wiki. So the project wiki has all the details. It tells what the PPI is, what the use of the project is, and all the demo credentials and API details are here. You can see what PPI is. And next, you can also see what the background is, how it came about. And you can see how it is useful, how MeFOS uses it. And finally, you can see the actual, yeah, like these are the purposes we'll use it for. And finally, I also made our Confluence page ready. So anyone who wants to know what the project is, they can just come to the Confluence page and like view everything about that, the requirements, how it was implemented, and our like my meeting notes with Nayan. So they can also see what all was discussed. And yeah, so this is the Confluence page. Also, like if you don't have an Android device and want to test the app, you can just go to this link and you can test the app online. So go here. You have to select this link, open it, go here. This is all online, so you don't need to install the app on your device. Actually, you can just install it over here on device of your choice. It will just install, and yeah, now you can just use it as of from your laptop itself. And the password is password. and login. Yeah, so this will just work similar to the Android app on the device. So you can just test it out here if you want to try it. So yeah, this was my this was most of the work I did, and if anyone has any questions, I'll be happy to answer them.
Well, thank you, Yash. Feel free if anybody has any questions to type them into the chat or the question and answer, and that goes for all of our presenters throughout the day. But very impressed with how much you were able to advance this project over the summer, Yash, and really looking forward to sharing this with the Innovations for Poverty Action folks to get their feedback. And then, this is a really neat use case demonstrating machine learning and object detection, and eager to have you as part of our community in helping us advance our roadmap around artificial intelligence and machine learning and how those can benefit the users across our community. So great work.
Thank you.
And also, I appreciate all the focus you put on the documentation to make sure knowledge could be transferred and people can easily get up to speed on the project. Really impressive there as well.
Thank you.
Okay. Thanks for your comment too, Bharat. And then next up, Garvit, if you want to begin sharing your screen. Garvit is going to demonstrate the various enhancements and new features he's built onto Mifos Mobile CN, which is our mobile banking app on top of our next generation cloud architecture, Fineract CN. Take it away whenever you're ready, Garvit.
Is the screen visible?
Yes, it's visible.
So hello everyone, my name is Gavit and I worked on Mifos Mobile CN. It is a customer facing app built on top of Fineract CN. So it basically provides various microservices to the customer in regard to his accounts, regarding loan accounts and deposit accounts. So my project included connecting it with the demo server, redesigning of the whole app. I redesigned the whole app with respect to the new designs which were proposed during the GCI. These basically included, there was earlier navigation bar. Now I have implemented bottom navigation bar and added much more options now. I have also integrated the payment hub e-dev environment in this, so we are now able to make transactions. So, and next I also implemented over SDK. This allow us to make payments by the use of USSD transactions in MTN Uganda SIM services. So, and next I also added a support for the transactions via the QR code. So with the help of QR code now you can make transactions. So one by one I would present you with the screen recordings that I have recorded and compiled in this presentation. Okay. So basically this is the login part. So this will allow you to enter, the login credential will allow you to enter into the demo server. Here it is, the user, and now you can, this is the passcode activity. So, and beyond which you have now the dashboard. So this is the redesign part. So in the redesign, I will simply brief you here. As you can see, now there are 4 tabs: home tab, accounts, transfer, and profile. And there are 2 options on this home tab: send, for sending money and receiving money. And now I will turn on this. In the accounts tab, you have 2 options for deposit and loan accounts. You can also apply for a new loan account here by filling all these details. Next, we have the transfer screen. Here is a QR code scanner for the mobile. Here is a profile. It will fetch data from servers. Once that. Here we are seeing the beneficiary list We can also add the beneficiary here, and these are the notifications. Currently we have no notification. So that's it for the redesign part. Next we have the payments. So I basically explained earlier, there are two modes of payment. This is the USSD payment for MTN Uganda service. This is implemented basically using the Hover SDK. And second, we have the direct payment. This is implemented with the help of Payment Hub Lab environment. So I will walk through you through both these mode of payments. We have the now we have selected the MTN Uganda service area. We are adding a description of the purpose of our sending. So currently I do not have a MTN Uganda SIM, so I could not proceed further. But I'll show you the screenshots which you will get up in the next slide. And this is the mode. This is the transfer with the help of the Payment Hub web environment. So as you can see, the payment is successful. So these were the screens that you will face if you have a MTN Uganda SIM. Your details would be confirmed once they are entered, and you will be asked to enter a PIN associated with the account. And after clicking on confirm, the transaction would be successful. I will also show you how I have set up this Hover SDK on the Hover dashboard on their website after this presentation. So, and this is the support for generating the QR code while entering the details. So currently there were no self-service APIs, so the user has to enter his data manually. Once those API are ready, this process can be automated. So here this QR code is generated now, and the customer can use it for receiving the money. The help the other person will scan this QR code and make a transaction. So this is the transaction part with the of scanning it. It automatically detects the MISDN associated with this QR code, and now you can make the transaction. So that's it for this slide. I will now show you the Hover SDK. So is this Hover SDK dashboard visible?
Right now, it's still just your PowerPoint window of it.
So now is it visible?
Yeah, it's visible now.
So now you can see this is the Hover dashboard. This is the mobile CN app. So I have basically created an user action for repaying the loan. So you can see like this, repay loan. So what all of options that I have added while making this action. So you can see that I have added the country as Uganda and the mobile network MTN. And all these code, the USSD code which works for this, and all the says this Hover SDK has basically automated all the USSD actions that would have to be followed manually. So it will take care of all of these, and now all this will function while in the app. So that's all. That's all. Okay, thank you.
Okay, thank you, Garvit, for that showcase, and happy to see all the progress you were able to make with the application. And I know you ran into a number of blockers, given some of the APIs weren't available in Fintech CN or the Payment Hub, and look forward to, having you continue efforts once those APIs become available. But thank you as well to all of the documentation and issues you raised on issue trackers to make sure what, future API changes were needed are documented and the community is well aware. So thank you again for all your contributions. And so next up, Shivangi. Let me see. I don't think Shivangi's on just yet right now. So I think we're going to then move into Manthan's showcase. So I believe you're already a panelist, Manthan, if you want to share your screen whenever you're ready. So Manthan was one of our GSOC interns through the Apache Software Foundation, and he worked under the mentorship of Michael Warburger and Awesome, and really accomplished a lot and made some extensive refactoring and completed our long-awaited Swagger API documentation. So Manthan, I think your screen is ready, and then we'll let you begin. And then Shivangi, I see that you're on as well, and I'll make sure you can showcase right after Manthan. So thank you all.
Hello, am I audible?
Yes, we can hear you and we can see your screen, Manthan. So.
Okay. I worked on basically worked on code refactoring, adding check styles, making Swagger UI usable. I fixed multiple security issues that were present in Finrack, increased test integration test coverage, and solved various small issues that came up during my work during GSOC. So before I start, I want to thank Michael and Vasam, who has been really great mentors. They helped me a lot throughout the GSOC process. So a summary of my project is that I have added more than 50 check styles. I'll take you through each one of them, that what exactly has been done there. So I added more than 50 check styles. I made the Swagger UI usable and will now move as a Swagger UI as our official doc, and will shift from the old API documentation and give a short demo on Swagger UI. I've also made a detailed video which is added in the README, so you can also check that. Other than that, I added code auto formatting. The Finrack code initially was not in a very good shape, and adding check styles was a big task. But along with that, to ensure that in future the check styles don't create problem for new developers, I've also added spotless so as to remove that ambiguity and problems that may occur. Then there were many security fixes that were done in Finrack. The main was removing the SQL string concatenation. So what happened was we were making all the SQL queries in string concatenation that is prone to SQL injection and various security threats. So we have solved that by using our own SQL builder module. And also there were some parameters, for example, SQL search, which were being used, which were not good for security purposes. So I have replaced them. Then I also wrote integration tests for Swagger, for audits, etc. And they are and increase the coverage, and I solved some of the small issues that came up. So I made over 90 PRs over the GSOC period, which you can see on the Finrack. So we'll start with check styles first. So what exactly was covered in check styles? So I have implemented around 50 to 55 check styles. So what check style does, it is a static analysis tool. That means before the code compiles, it will analyze the code statically and find if there are some pre-known bugs or errors that might occur or that this code might lead to, and it tries to solve them. Along with that, it also controls how we write our code. For example, if I'm this is my code, so if I'm not following proper indentation, let's say I'm also not giving proper spacing, or maybe I'm trying to name the integer as ID, which I should not, because there is a proper naming convention. How should we follow? How should we name the parameters? Maybe I'm having an empty catch block. All these are the pre-known bugs. There are some common convention that we must follow when you have such a big code. And so for doing that, for having, or maybe some places I give a bracket in the condition, some places I don't. So this is not a really good practice. So to keep a check on all the code that we are having, we must have a set of rules that our code goes through. So it is called a static analysis. So that's what we do in check styles. So for example, these are all the check styles that are active now. There are more than 50 check styles that are active. So all these check styles work. So like how the white space is there, how the members are member in a class are named, are there redundant modifiers that if in an interface we may not use a public we not use a public modifier, so why do we don't need to add that, etc, etc. Or maybe even control how this the order of public, static and final, like the different users might write it in a different way, so that is also not it is good to have consistency. So even now we control like in what order these are written. So this all checks are added and the code won't build if this following checks are not followed. So it helps us to maintain code quality. So let's see. So let's say, for example, if I am leaving so how are this implemented exactly? So to implement one of the check style, what I need to do is I need to add the check style and fix the pre-occurring bugs, pre-occurring errors. So when I fix the pre-occurring errors, now the check style can be added, and in future, no one is allowed to make that error. So for example, there were many empty catch blocks. Some of them required some work and some of them required only a log of the error that is occurring. So my task to add an empty catch block check style was to add was to fill up all the catch blocks with some relevant code, and then now if I'm trying to have an empty catch block in my code, the check style will give an error and not let the code build. So this is one of the example. The other example can be how we name the parameters, let's say. So it is not this naming convention is not generally followed in the parameter, like we need to follow the camel casing generally. So this is the standards what we know and what the check style defines. So I replace all the names, naming check styles. This is how that works. So we all replace all the incorrect format names to the correct format names. Or maybe it's not a good practice to throw general throwable class. We should always throw some relevant, whatever the exactly exception is. So to solve that, we add the illegal throw exceptions. We need to remove all the throwable class, whatever, whenever we throw throwable class, we are adding a good practice again. So this is how the check style works. So there are more than 50 check style on different parameters. They are analyzing our code, and so the code is more clean and it helps us to avoid hidden bugs. Like the empty catch block may cause hidden bugs that we may not identify. Like it is not a good practice to have an empty catch block. So that's how the check style works. So over 50 check styles were added, and now the code along as we write is naturally naturally of good quality. So before I come to Swagger documentation, so I'll tell you why the code auto formatting was added. Now see, if we are controlling everything in our code, let's say I'm controlling the number of spaces I give even here. So while or maybe I'm having some unused imports, etc., etc. So whatever, or maybe I'm writing public static or final static, something like that. So developer needs to worry about 100 things now. So when he needs to worry about 100 things, the development process will get slower, and that's not what we want. So some of these fixes are static. That is, I cannot fill an empty catch block, but I can definitely reorder them like a public static final. I can reorder them themselves. I can pick these spaces that I'm having. So if I'm having let's say wrong spacing, so we can use something called as spotless auto formatting. It itself implements about 40 check styles, like whichever it can. So when I run the command gradle spotless apply, it will go through my all the code, and using the predefined rules that I've added, it will format my code in the desired format, so that to pass the check style. So when this completes, all the spaces will be removed, all the extra everything will be covered. So we'll come back to this. This is working. It will take some time. So this is how code auto formatting works, and in this actually changed about all the files, and wherever there was unintended indentation was not proper, or we are having big lines, all the lines are wrapped. So the code quality was immensely improved in this part as well. So this is completed, and you can see that all the spaces are now fixed themselves. So everything is now in order as it should be, and I did not worry while writing code, am I giving proper spaces or n number of things, and the code quality is maintained along with that. So this is what the code auto formatting does. This was about it. So next, let's see what happened in Swagger. So Swagger UI was worked on for like 3 years, and it needed final touches along with the ongoing contributors. I solved about 5 to 7 minor to big issues in Swagger UI that now it is in working condition. It is the latest version. We are using now using the latest version of Swagger UI, and we are on this place to have it as a standard documentation now. I have made a demo video which you can see if you're interested in more detail. I will give a short demo of how this works. So the old version of old documentation, as you can see, this was a big HTML file and it was static documentation. So whenever I make a change, let's say I'm adding a new parameter, I need to go to this documentation and edit it. So this is not really it is okay, but it is not really a good. We can have some better approach here to manage this documentation. So we came up with Swagger UI. What Swagger UI does is it generates a finrack.yaml file that is generated during the build time. This finrack.yaml time is used by this web interface to generate this entire documentation. So what is exactly the difference is this all this text you are seeing or all the API definitions are written within code itself. So this is this Swagger UI picks from the code. This description we write it where the API is defined, so that a user need not go to 10 different places to change it, but while writing the code itself, he can adapt to the changes. So the API documentation will always stay up to date and it will also be more convenient. So this is also live now on this URL on the Finrack demo server, which you can see. And so how this I will give a small demo. So if we are having multiple servers, we can choose a server that we want to operate on. We can enter the, initially we are for convenience given a default ID and password, but we may log in as different basic auth, like whatever user you want to log in as, or change the tenant ID if required. So this is used to try the API in the browser itself. So for example, if I'm trying an audit API, so I'll search audit. This is case sensitive. So I'll get all the APIs related to audits. I'll go here. I'll say I want to get all the audits. So I'll click on try it out in the browser itself. I can give some parameters to it. Let's say I want with the action name update, and I will execute the API in the browser only. So I'll get all the API call results and what exactly was the response headers, etc. What URL was generated to make the API call, and etc. etc. So all the information is given. So this is how you can try the Swagger this API documentation in browser. So the one who want to test the API can also test it quickly and nicely in this browser interface. So this is about the Swagger UI part, and the whatever user is authorized, the same is used to make this API call and then get the results. So this is how the entire Swagger UI works. So we are completely shifted, and we just need to I verified myself, but I'll take some more time and thoroughly verify that all the APIs are correctly working. I'm sure they're working, but just to make sure once again, because we are trying to remove all documentation completely. So that should be I should be 100% sure that everything is covered and everything is properly done. So I think we can in 15 or 20 days, maybe, as soon as I do the remaining verification, we can completely move on the Swagger UI and completely remove or discard the old documentation. This was about Swagger UI. Now I'll move to the SQL string concatenation. So this is one of the example where I removed SQL string concatenation. So let's see. So what exactly happened was we were initially we are trying to concatenate all the strings like this. So we are appending all the SQL queries along with the SQL queries in a string builder, and we are trying to make an SQL query like that. Now that is inherently prone to SQL injection and n number of security issues that we may not even think of. So to solve this problem, we have made an SQL builder, which is a module that is used to create these SQL queries and takes care of all the security things that needs to be covered, and it is also more faster. This was done in multiple modules. So this is the example in staff, for example. And I also removed the SQL search. That was a parameter that was added to multiple APIs in our Finrack, but it was not safe to have that because it was giving user direct permissions to interact with the database. So that was in the security point of view, it was not good to have the SQL search parameter. So problem of removing SQL search parameter was that if we are removing SQL search parameter, then we need to add relevant parameters that is needed by the front end. So for example, I added the status parameter in client's API that was needed since we removed SQL search. So this included writing the code to this wherever the SQL search is stopping, wherever the SQL search is used in front end, we now need to replace its use in backend. So that was done here. So the status parameter was added. So similarly, parameters were added, etc. The work was done. and there are one or two modules that the PR is still open, and we need to merge that upon the proper reviews, but rest of the part is done. So nearly all modules are converted to the new SQL builder part. Check styles are nearly all check styles are added. Some of the very hard to implement check styles, like changing the name of every variable. There is a place where you have to change the variable of the constant. Some of the check styles are left. 3 or 4 check styles are left, not many. So that can be a future prospect, or maybe we don't do that because that is not necessarily required. Code auto formatting, no work is left. For SQL string concatenation, I will only finish that, like 1 or 2 PRs are yet to merge, and that will be done. The last part was improving the integration test coverage or solving small issues. So like there were no integration tests for in audit trails or many other places. So my task was to find all those places and add the integration test. So I added about 5 to 6 integration tests in audits, and similarly that was done. So I improved the integration test coverage a little bit. And there were some null pointer exceptions or the problem that were coming in the log during my work. So I picked up those and solved some of those issues. That's all. So I plan to do the similar work in the future, or be a mentor in future in Fintech. So that's all from my side.
And then Montana, I think you can see it as well, but James had a question in regards to the Swagger documentation. His question was, is there a way to add further documentation automatically into the group the APIs in a hierarchy?
Yes. So like when, so I can show you if I can find it easily. So whenever we are writing the documentation, let's see. So how this works is whenever I'm having a new, let's say you're adding a new API or new parameter you're doing any change. So all you need to do is use some annotations like the description tag annotation. There are Swagger annotations that are used. So here itself will make the change that is required while you are making any changes in the API, something like that. So let's say I want that add some more information here, or I want to make some change here. I wanted to call, this is how it got the it is called as action name, because we have mentioned it that is called action name. So you can change it here. So there are a number of annotations that we need to use. So there is a documentation present, but we can also make, I am planning to that. We can make a documentation specific to Fintech on how to add more annotations, or how to add these annotations. So these annotations are used then to update the Swagger UI. So in case you are adding a new API, you can directly implement while writing the code itself. So it won't be very hard.
And then hopefully that covered your question, James. So. And then James did also ask Manthan about and then grouping of the APIs in a hierarchy. How is that handled automatically by Swagger?
So I'm not reading the question exactly. Are we concerned about how the APIs are grouped together like this, or we need a hierarchy of? Okay, so the APIs are currently displayed randomly, and they should be in a proper hierarchy. Is that the problem?
Let me try to unmute James if he wants to directly verbalize his question.
Okay. Yeah, that was the question. How to put them in a hierarchy.
Okay, so Swagger inherently does not provide any way to do a hierarchical API structure. It is one big page again for a hierarchy. But there are some implementations that are present over Swagger UI that can be one of the future prospects of this project, that we have a sidebar here and we are giving proper hierarchy. But inside Swagger, there is no way that we can directly add that, best to my knowledge. So that is currently not possible. but there are some, I am aware of some implementations of the Swagger UI that can be used to have a hierarchical structure. So they are not part of Swagger. They are made by third-party organizations other than Swagger. So we may use that in future. But currently, as Swagger stands, we have only one big page of we are not properly hierarchical. There is no group structure as such.
Okay, great. Thank you very much.
Okay, thank you for that question, James, and thank you, Manthan. Really impressive how much you're able to accomplish both before and during Google Summer of Code, and you really become deeply and intimately aware of the Fineract code, and we're looking forward to working with you in the future on both Fineract as well as Fineract CN. So thank you again.
Thank you.
And then next up, I'm going to allow you to share your screen, Shivangi, and I think you're logged in as Ashwin. So we're looking forward to seeing your showcase on the Mythos mobile banking application on top of Fineract 1.x. So feel free to unmute yourself, Shivangi, and begin sharing your screen. Shivangi, I think you came off mute, but we weren't able to hear you just yet, and your screen's not yet visible if you were trying to share. So.
Hello.
Yeah, we can hear you now, Shivangi. And then are you able to share your screen?
Yeah, 1 second. I'll just share my screen.
Sure.
Can you see my screen now?
Yes, it's now visible. So.
Yeah. So hello everyone. This is Shivangi, and I worked on the self-service Google Summer of Code 2020 with NEFOS initiative this year. So for the showcase today, I'll be starting with the overview of my project and goals achieved during this period and the next steps for the project. So I worked on the NEFOS Mobile 5.0, which is an updated version of 4.0. And the app is built on top of NEFOS X platform. So the features currently include making transaction account statements, adding beneficiaries, and storing all the details related to the account of the user. So talking about the milestones achieved during this work period involves adding theme support, redesigning the UI, payment hub integration, adding the passcode feature, and I also worked on minor bugs which I faced or found while working on the project. So starting with adding themes, so the application supports 3 basic themes now, which is light, dark, and system default. So the dark theme is added so that it reduces the screen glare and is more suiting to eyes because of the low light conditions. So here is the screenshots of adding the dark theme. Next up is the adding of the payment hub integration. So the payment hub allows to make transfer from one account to the another by using the payment hub APIs. So right now the payments are just initiated and supported only for the registered MSISTN numbers. Like I worked on it, and right now only the users which are registered through the number can only transfer as of now. So as a later part, I'll be expanding it to allow payments for new users as well. So here is the implementation of how it works. So for a given MSISTN number and the amount, we can make the transactions. Next is the Rocket Chat integration. So this feature is added so that we can allow the users to allow a real-time chatting system for our application, and this was no
Oh, Shivangi, we're losing your audio at the moment, so. Oh, Shivangi, I think you've got a connection issue as all of your audio is dropping out and distorted. Oh, and then
there was no passport feature, then only he or she has to.
Oh yeah, Shivangi, you might need to set back a screen on your presentation as your audio cut out for about 45 seconds or so. So you cut out when you were speaking to the Rocket Chat integration. So if you wanted to resume from there, that way we can pick up where you cut out. And then your screen's not visible right now either, so you might need to restart screen share. It's just starting up again. So. You might want to stop and restart the screen share again, Shivangi, as it's just frozen right now. So.
Okay.
Yeah, resume now. The screen is visible.
Okay. Yeah. So yeah, talking about the Rocket Chat integration. So as of now, I added the library over there. So this library is like updated with the callbacks, and there is like all the decline requests also added to the library. So further, after getting the updated APIs, we'll be able to integrate into the application. So this is like one of the work left for the further scope of the project. So next up is the option to add the passcode feature to the app. So like earlier there was no option to change the passcode, just there was a feature to change the password. So I added the feature for changing the passcode, and now whenever the user logs out, then only he or she has to change the passcode. Otherwise the pre-saved passcode can be used by the user every time they log in. So next up, talking about the UI redesign. So so here is the like the bottom navigation designs by home option. This is the accounts where you the user says, so this is the home savings, loan, and share, and this is where you can initiate payments through QR code. Next up, this is the user details section. So earlier there were few details which were not getting updated even when the new user comes in. So I removed all those unneeded details, and this is now being the most precise data we can use of a particular user. And here is the about us section, which is a little improvised with what it was. So talking about the next steps of the project, so I'll be completing the Rocket Chat after after getting the APIs, and also there is a bit scope for the UI improvements. So I will be working with that, and also have to take up the general maintenance of the project. So and thank you for your patience and hope it was informative.
Okay, thank you for your work this past summer, Shivangi, and we're looking forward to continue working with you to implement the remaining scope, and then also, begin to leverage the work of Jinmei around the Android SDK, and then also the work that Ashwin did around converting to Kotlin. So great to see we're continuing to evolve our mobile banking app on Fintech 1.x. And then Nasir, I think you're up next. So if you want to begin sharing your screen, we'll move into your showcase of your project around migrating the ORM from OpenJPA to Eclipse Link.
Thank you.
And we can see your screen, Nasir, and
Hello?
we can hear you as well. Yeah, all good to go.
Yeah. So I'm GMT20200910, Nasir, and today I'll be talking about work I've done this summer on migrating the ORM from OpenGPA to Eclipse Link. And so first I'll talk about the project description, then implementation, the difficulties and challenges, and the future work. So as described, in the project description, this OpenGPA, that was the GPA provider that we were using in the project for like several years. It has been reducing, project contribution, and it's not getting maintained as expected anymore. And we want to migrate to something that is more constantly maintained and can be more reliable, with future updates and so on. So that's why we're doing this migration. And during this summer in particular, the first thing I had to do was to replace the GPA provider in the persistence.xml. As you can see here, we have some quick stuff that can notice here. We have Eclipse Link weaving. We're using static weaving, GPA entity weaving, because we tried to use dynamic weaving, but that was not possible because we had to use the Java agents. That would be more confusing to distribute once the product is released. And I used a high level of logging because the most part of this project was a lot of debugging, because a lot of errors that came up did not really make sense. So I had to go into really deep debugging. So I had a very fine level of logging. And we have GDBC batch writing, trying to persist many entities at once. This is really exploited maybe when you're using a table for ID generation, where ID values can already be foreseen before entity persistence. And yeah, so next thing is weaving or enhancement, NT enhancement, which is a GPA spec, used to monitoring GPA entities, enabling things like lazy loading and eager entity loading, making that possible. So so I tried to achieve this. It wasn't really easy because there weren't some predefined spec in the documentation for me to achieve this. So the thing that was closest to the reality was an anti-task that I saw somewhere in an Eclipse Link documentation, 2012 or so. So I updated the task into a graded task, which I've represented here. And this task basically does the weaving during compile time, so that just all the jars are compiled and enhanced at once. And yeah, so the next thing, we had to handle a lot of default constructors during the migration because unlike OpenGPA enhancement, Weaving here does not add default constructors to entities by default. Like, because as I realized that OpenGPA enhancement just added default constructors to entities that don't have a default constructor. This was like, it's a GPA spec that omitting to add was like part of bad practice, because creating a Java bean requires to have a default no arguments constructor. Next thing I needed to add the GPA system exception as an exception for the GPA transactions. And while carrying out the test, I realized Eclipse Link did not throw them the same exception errors like Eclipse, like OpenGPA did. OpenGPA could throw like data integrity violation in case of an error, but Eclipse Link always throw a GPA system exception as a standard exception during when an error occurs in the code. So what really brought my attention to this was an IT test that we had to run, and the IT test was meant to return an error code, like after you have scored an exception, but that didn't occur. So that's really what brought my attention to this. And this I pulled this and I made this change on OpenGPA, and it's already been merged, the current release. And yeah, so also had to adjust some GPQL queries, like property referencement in some queries were not properly handled in the code. Like we have this likelihood, like this particular query where we try to access the PPI name of the likelihood entity. So you have to do entity.property reference, not just column name, because we have the parameter name, the PPI name, but we did use a different name here. Like this was the column name that we used. But I don't know, this will work with OpenGPA, but Eclipse Link had to change the whole definition for it to work. And yeah, and the last thing, I think this is still something that's under discussion, and I've already raised a PR for this, is the new generation strategy that we're trying to adopt for this. So we're trying to adopt table generation strategy for ID generation, because I realized during persistence that the IDs for the loan installments were not generated fast enough. They were really generated like really slow, like maybe towards the end of the transaction before the IDs were generated and assigned to the column, and that caused a lot of SQL integrity issues. So I created an abstract auditable table, a table abstract auditable class, superclass for this, where I use table as an ID generation strategy, but I only specify this only for the loan repayment schedule installment class. As we discussed in the mailing list, they try to propose this as a, try to implement it as a global generation strategy. But this didn't work because I did a lot of trials and I wasn't able to achieve something meaningful, because the way the IDs were generated did not really make sense, because like this is a sample of a migration that I did that could work with the general ID generation strategy as an abstract persistable custom class, but the damage control was not, it went well over beyond handle, because I was not able to control the way IDs were generated, and as a consequence, a lot of tests were failing because duplicate columns, duplicate primary keys, and yeah, especially duplicate primary keys. I was not able to control the way the IDs were generated, so I decided to only focus on the failing class, because I think that way it's more easier to manage and control. But that's still under discussion. Maybe someone has better way of approaching this. But in my opinion, limiting it to just this class is way more easier to control what's happening with the ID generation. Yeah. So basically, difficulties. The main difficulty I had was this saving, the ability for the GPA to save entities. That was not really possible. I don't know why, but I realized the entities were not saved at when the save method was called during the transaction, but later on in the during the run process of the program, like when if I call this save here, the IDs is not generated and the entity is not saved immediately. It's maybe saved later on during the run of the program. That really caused a lot of problems maybe during IT tests because there's some entities that needed to be saved then reused later on in the program. So I had to change a lot of save into save and flush so that changes are committed immediately to the database and ID is generated promptly. So I'm trying to read because I also needed it seems like a lot of save and flush costs had some performance costs. So I had to break through each save, to find the ones that were really important for the particular test or the particular case where the immediate commit was necessary and convert it to a save and flush. Yeah, slow ID generations, as I already mentioned, that's the reason why we have the table as an ID generation strategy because the IDs were not generated fast enough, and I couldn't find a reason why. So as a last resort, I just went through with the table as an ID generation strategy, where IDs already allocated and just assigned to the entity when they're created. And entity enhancement and the GP queries like that were quite tricky to come over. So what's left? I still have like 4 IT tests that are failing after all these changes I've made. These are mostly recurring deposit tests failing due to computation. You have some interest calculation that are not giving the required outputs when they are compared in the end of the test. So those are the 4 tests that are actually failing right now. The next thing to do will be to increase the test coverage because we can't really ascertain the reliability of this migration right now because a lot of tests failed before and we cannot be sure how many tests will fail after because we don't have enough test coverages and we cannot really guarantee that the test, given that the tests are passing now means it will work properly once the project has been released, maybe in production environments or so. So we need to increase the tests so we can really guarantee that the migration is really reliable. And also need to improve the performance and optimization of the migration, making queries faster, reduce execution time. Thanks. Any question, you can get the question here or you can send an email on the mailing list. Thank you.
Well, thank you, Nasser, for walking us through, the challenging project you had to take on this past summer. And we really would like to, get this completed by one of the next upcoming Finteract releases. So we'll continue to try to get all hands deck in the community helping with the issues you're trying to overcome. So I'll continue to try and get others to help you troubleshoot these as you have been doing on the list already. But thank you for this work on this much needed and difficult project. So last up, we're going to have, thank you, Nasser. And then last up, we're going to have Ankur. And Ankur, while you're beginning to get your screen shared, Ankur is going to walk us through his project, which was to create a new reference mobile app. So a reference open banking fintech app to help demonstrate how you can build a standalone app that is interacting with open banking APIs. So Ankur, I'll let you begin sharing your screen and take yourself off mute, and looking forward to seeing your demonstration and showcase today.
Hello. Is the screen
Yeah,
visible?
we can hear you and see your screen, Ankur. So.
Yeah, so I'll begin with by overviewing my final report for the Google Summer of Code. And yeah, so basically for the first few weeks, we focused more on research since it was quite an open-ended project which we were working on. First challenge was to we didn't have an SDK to uh, to make API calls, and then we were stuck on deciding the technology to use to build this project. So yeah, so I'll now first begin with how we choose open banking project. So basically, we didn't have an SDK to make API calls and authenticate user and build the demonstrate the apps. So I used this sandbox by open banking project. It's quite famous and used by many developers out there. So it's also open source, and you can find its code on their GitHub, right? Yeah. So this is the sandbox we use for our open banking API calls. And this major research we did was in the authentication modes. So basically, to authenticate the user with the app, there were quite few options we had, like auth 3.2 or 2 plus OpenID. OpenID is basically a unique ID which is required to connect using an external server. So we can have an external server. Currently, we have implemented direct login to authenticate the user, and there's one more option, that is gateway login. In case you want any further information on that, you can just go here and explore. Yeah, next we explored major use cases for account information service provider and payment information service provider. Yeah, and I also discussed some of the advanced use cases with Ed and my mentors, which were recommend products to the user based on their transaction history. An example could be recommending better deals and insurance. And then we can also have targeted ads based on the policies and products user own. And lastly, I propose to have provide users with analytics in terms of graphs, pie charts, etc. So all these use cases have not been implemented. These have only been discussed yet. Yeah. Next, another challenge that we had was to choose Kotlin native or to go forward with Flutter. So for that, we had an extensive discussion with my mentors and other senior mentors in the community, and I had tried both Kotlin native, vanilla clean architecture, test-driven development project, and then Flutter also. And then after this long discussion about pros and cons, we decided to go ahead with Kotlin native, as most of the code was being shifted to the Kotlin, and suggested me to go ahead with Kotlin native. And then after a few weeks, we started with the code. Yeah, major challenge was to define an architecture, because this will be a cross platform app. We want the developers of Android and iOS to seamlessly use the common code. So let me first explain how Kotlin multi-platform project works. So basically, you have this common module, which is basically the backend of your code, and it includes the data domain layer and the view model layer of the project, right? So this is basically the backend of the code, and it contains all the business logic as well and other things. This code is basically used by the Android app, which is a module which only builds the UI for the app. And then we have iOS app, which also builds the UI and calls the view model to fetch the data for the UI, right? So we have three main directories called common. It It is basically a Kotlin native module to share code across multiple platforms. Currently, we are supporting Android and iOS, but later on we can have web app or Windows app as well, or any other platform you would like to support. The common module is further divided into three modules, which is Android main, which is basically the Android specific backend code, which is used by common main. So basically, how uh, how to gain access to the Bluetooth or maybe a GPS is different in both Android and iOS, and for that we need to have a specific code. So all the platform specific backend code is implemented in here, and then common code across all platforms is in common main, right? And so this core library module is based on model view model clean architecture, and we use live data to have view model. So major issue here was that Android, basically Google does not have any support for their own live data, and we can't basically use the and Google's own live data library because this is Kotlin native and that won't be compiled on iOS, right? So we had to use other open source library and come up with our own implementation sometimes. So basically this common library is imported as .jar in an Android application and .framework in an iOS application. This module contains view model, data and domain layers. All the open banking API interaction is implemented in this module. And yeah, like currently we are using the open bank project to call the APIs since we do not have the history here. Now you can look at the view models, API, data layers, and all the use cases by going on this links. Yeah. And then these are basically server information like API host and consumer key, demo credentials. These are the overview of the use cases we have implemented. First, there is authentication, then sign up, fetching all accounts, fetching account balances, create a payment request. So basically, these two belong to AISP use cases, account information, and then this is payment initiation. You can basically create a transaction request, and if it's under some limit, it gets it gets success right away. Otherwise, it's transferred to the admin to validate this transaction request. And then this is basically this category belongs to payment payment information. Yeah, like here we have payment initiation service provider, right? So these are basically the use cases that we have implemented. For the documentation, you can just go to the wiki. Here I have written down how to build the code on Android and other guidelines. And I have also explained the architecture, how is the backend and the project interacting with the UI, the open banking project backend and the use cases. And then, so I'll now, this is the repository. I'll now show you the demo. So yeah, this is the RAM. I'll just put demo credential here. It shows all the bank accounts which are linked with my open ID. Now it basically fetches the account, and to fetch the balance, I just had to click on fetch balances, and it shows the balance associated with each account. Now, in case we need to create a transaction request, I can just go on the bank. I want to create one. Let's say I choose this bank account to create a transaction request. So yeah, sorry, yeah, this basically shows the request that I have created earlier. So once I created with €1, and this basically is the description of the transaction. It says that the requests were made from this account RBS underscore _ @RBS to HSBC underscore HSBC underscore test. Right. So let's say I initiate a payment now. Say HSBC underscore _ and then I put the bank name, which is HSBC test. Yeah. So let's say amount is 99, and this is the showcase. Description is showcase. Now I proceed, and it says money transferred successfully. So basically there is some limit. I guess the limit is €1,000. If the amount is less than that, the payment gets validated and approved immediately. Otherwise, it goes to the admin to validate the payment. Now, if I see the transaction request made from this, it says there is one request of €99, which were made from this account to this one, and the description is showcase. Right. So this basically in the green is the transaction request ID. Now this request is also assigned with a transaction, right? You can look at the transactions here. This also shows the total accounts and assets that you have spent in last 30 days, and or maybe credited and debited, right? Yeah. So these are basically all the use cases that we have currently in the app. It automatically fetches the supported banks that we support with the OpenID, and yeah, that's all.
Okay, thank you, Ankur. And as an immediate next step, as we've been discussing, it would be really important the app and SDK that you've built to be interacting with the open banking, the limited set of open banking APIs that have been exposed on top of Fineract for the ACE Fintech use cases. So ideally, we can start to get your app to consume the same APIs that ACE Fintech was consuming, as would like to make this the reference, third-party open banking or PISP application that we use as part of our lab environment for the open banking and PISP use cases. So eager to continue work on that with you, but glad that we've got the standalone app and SDK in place, and eager to now start integrating it with the open banking APIs that are exposed on the Fineract side.
Yes, Edward, I'm also looking forward to integrate our own SDK into the app now. Yeah, and
Okay.
sorry about not attending this week's weekly check-in, because I was really caught up with the college work.
Yep, no worries. Okay, well, thank you everybody for your showcases today. Just a reminder, this upcoming Tuesday and Thursday, we'll have parts 3 and 4 of our 2020 Google Summer of Code showcases. Shortly after this meeting, I will send around the recording, with a timestamp for each of the respective demos. But once again, thank you for all those who attended, and thanks to our interns for their efforts today, and most importantly, their efforts throughout the past summer, and looking forward to continuing your journey in our Mifos and Fineract communities. So thanks, and hope to see you all on our next showcase this upcoming Tuesday. Everybody have a good rest of your day, afternoon, or evening. Take care, everyone.
Thank you for having us.
Thank you.